Hello scholars, welcome back. Mr. Hinkle here. Let's talk about igneous composition. Now, igneous rocks are rocks that cool from a melt. And there are two types, igneous intrusive, forming from magma below the surface, and igneous extrusive, forming from lava above the surface. When we're looking at physical characteristics of igneous rocks to classify them, we look at texture, discussed in another lecture, and composition, the point of this lecture. We will define igneous composition and then describe the four distinct igneous compositions and then discuss the importance of them. So, igneous composition is really looking at the mineralogy, the types and proportions of the various minerals. And we can have a zoomed out look using the light or darkness, the color of the rock, all the way to a very zoomed into the actual percentages of various minerals that make up the rock. So this is going to the minerals, which are defined by the chemical composition, the chemistry of the rocks. Chemistry is woven into everything we do, and it's a very important aspect of understanding rocks and minerals, affecting their physical and chemical properties. And then, as I mentioned, composition is one of our two key determinants of rock classification. So, igneous rocks are divided into four groups based on composition: ultramafic, mafic, intermediate, and felsic. Now, we can look at it as the color, from very dark to very light. We can look at it as the amount of silicon oxygen, from very low to high, or the amount of iron and magnesium, from high to low, right? These are elements, silicon and oxygen, magnesium and oxygen, iron, that make up the chemical bonds that compose the minerals. So again, composition reflects the mineralogy, which is a product of the chemical bonds and the elements that are available inside of those rocks. Let's start. Felsic. Felsic is going to be our lightest rock. So it is light in color, high in silicon oxygen, low in iron and magnesium. Now there's a lot of other things going on, right? More complex than this, but for starters, this is a good place. So a very light rock would be granite. Granite has a lot of quartz, a lot of feldspar, silicate minerals that have the silicon and oxygen tetrahedra. Awesome. Pick up this rock, see that's light in color, identify it as felsic. Okay. Intermediate. So intermediate is because it's between felsic and mafic, which we'll talk about next, right? But intermediate is slightly darker than felsic. And again, it's SiO2 is going to be intermediate, SiO2, and then intermediate iron, magnesium. I apologize if I'm off the board here. Common rocks here are diorite and dacite. Now we see a rock darker. So we can all pick up a rock and say, that's light, that's dark. That's light, that's a little bit darker than this one. Intermediate composition. Again, the goal here is to put a name on the rock for classification, and then use that classification in order to determine geologic history. Let's keep going, shall we? Mafic. So now these are typically dark, appearing very, very dark gray or black. They have low SiO2, so low silicon oxygen, and then they are high in iron and magnesium. Here we commonly think of gabbro or basalt. So this is a gabbro. You can see the large crystals. Maybe zoom. Whoa, whoa. Sorry about that. Felsic to intermediate to mafic. So we're starting to see a transition when I put them all next to each other. Oh yeah, there is a gradient of color that exists because of the varying chemical composition by the abundance of the minerals. Let's keep going. Peridotite is known as ultramafic. And this one is extremely dark or green because of the mineral olivine. And then it's got very low silicone. We'll go very low SiO2. High proportions of iron and magnesium. Here is peridotite covered with olivine. This is the material of the mantle. Iron and magnesium are a little bit heavier than silicon and oxygen, so they sink, they compose and create mantle rock, which is peridotite, which is solid but can flow very slowly over time. Given certain conditions, magma is generated. But peridotite is an ultramafic rock. Going to chemical composition, the lowest amount of silicon and oxygen. So this is a really cool graph, figure I guess, that shows a lot. Silica content from low to high. Iron and magnesium from low to high. Minerals, feldspar, quartz, another feldspar, muscovite, biotite, amphibole. Pyroxene, olivine. Compositions, felsic, intermediate, mafic, ultramafic. So felsic rocks have these minerals in these abundances. Intermediate rocks have rocks in the, or intermediate igneous rocks will have proportions of minerals, like so. Here's percentage of minerals by volume. Mafic, we're going to have more pyroxenes, some plagioclase, no orthoclase, no quartz. Ultramafic, primarily olivine pyroxene, reflecting the silica content that is also dictated by the minerals. So, igneous composition. I was going to do a conclusion, but I'll save the conclusion because we want to talk about what does this tell us? Well, this tells us the geological processes occurring in Earth's crust and the mantle. It tells us about the nature of volcanic eruptions, the cooling history of the rock, and then we can also figure out the tectonic setting in which the rocks were formed. Peridotite, oh, down in the mantle, scraped up through convergence zone. Awesome. That's how we know. I'll talk about that more in another lecture. But understanding igneous composition reflects the conditions, the magma of the environment through which these rocks were created. It's important for us to be able to determine or classify igneous rocks, because igneous rocks are rocks that form by the solidification of a melt, and they have various textures and various compositions. Composition ranges from felsic to intermediate, mafic to ultramafic. That's what we got for igneous compositions. Thank you so much, and I'll see you again in the next one.